Here I am going to discuss about de Moivre's theorem. To understand this theorem, I must know about multiplication of complex numbers in polar form. So here I have taken two examples, z1 equal to r1 theta 1, z2 equal to r2 theta 2. If we multiply these two, so it gives us r1 r2 theta 1 plus theta 2 with plus sign. So what it says? So we have to multiply their moduli and add their arguments, because this theta are the arguments and these r1 r2 are the moduli. Now if we take two complex numbers, what will be the result? R square, because same as multiplication of complex numbers, and it will be 2 theta, because add their arguments. In case of three numbers, as per this it will be r3 and here it will be 3 theta. Now question is, if instead 3 if we put n, so what will be the result? Surely it will be in general form, and in that case we can write this to the power n equal to same as this r to the power n and n theta. This form, I mean this general form, we call it as de Moivre's theorem. It has some limitations. What is that? Theorem is true for all positive, negative and fractional values of n. And this theorem, it is used to determine the power and roots of complex number. So let's see first how to determine the powers of complex numbers. Here I am plotting a diagram which is Argand diagram, because it must have real axis, imaginary axis and the coordinates having a distance a and b, because our complex number is z equal to a, b, j. A is the real, b is the imaginary. So here I am showing angles. So it is showing this theta as well as r. So we can explain this Argand diagram as, because we plot this complex number as a coordinates a, b, and real part of this z, it is on horizontal axis as a real axis, and the imaginary part of this z, I mean b, it is on vertical axis as an imaginary axis. Now these are, already I showed here, this is a right angle triangle, and the distance of this point AB from the origin, it is known as modulus. From AB to origin, this distance is modulus, and this modulus we can find, say, like this. As it is a right angle triangle, so it is easy to calculate a square plus b square, a square root. Now for this part, argument, it is, we have to calculate an angle between the positive x-axis and the line joining this AB to the origin. So this is the argument. That's why we can write argument z equal to theta. Now let's see our example, this complex number on a graph. Say here this complex number, the same point AB, I am taking here also point here. This is a point for this. Of course it will be 3, 4. And then here I am taking this theta, or it is not theta, here I am putting alpha. I am going to explain why to alpha. First I need to find the modulus. So modulus will be same formula, 3 square plus 4 square, square root of it will give 5. So we got the modulus, I mean this distance here from here to here, this distance. If we consider this as a right angle triangle and this alpha, it will be, because this vertical distance is 4, horizontal distance is 3, so surely our value for alpha, it will be tan inverse 4 by 3 equal to 53.13 degree. But here we define that this theta is argument. But here this alpha is not argument, because here condition is argument must be measured from the positive real axis. So how to get that? This argument, it will be say 180 degree minus this, we will get this angle. What is that? This angle. It is 126.87 degree. So this is satisfied because it is measured from the positive real axis and it is 126.87 degree. Now it's perfect. So surely polar form, we can write this complex number as this. R value 5 and this is argument 126.87 degree. So let's move ahead to see more of it, because we need to find the value of this, because our target is to find the powers of a complex numbers. So it is same diagram and the value already we have seen. We got 5 and argument is 126.87 degree, this one. Now we have to apply the Morphers theorem. So what we will do, applying this theorem, we can write, because it is with powers. Our target is to get the value with this power. So this is 4 and this one we can write in polar form as this, because as this one. So we wrote it and it has power 4. So already we learned if power is 4, how we can write this? We can put this modulus to the power 4 and argument to be multiplied by 4. Our result will be this. I am talking about this one. 4 into 126.87 degree. If we multiply it, value 507,480 degree. But we have to consider this because we have to deduct 360 degree. So our value we will consider here as 147.48 degree as the argument, and this will be to the power 4 625. So our value will be 625 147.48 degree. This is in polar form. So we got it. Because here it says express the result in polar form. We got it. Now it asked to get it in rectangular form. So what to do? We have to bring this r cos theta plus j sin theta. Let's put the value for the theta. Because r is 625 and theta already we know this. And this value also we know. So getting all this value with calculator, we get our value as minus 527 J336. This is the value for this. Surely so it is the value for with this power. And it is in rectangular form. So we got both polar form and rectangular form. And we understood how to get the powers of a complex number. And that's all for today.